If you flip to the back of your cheat sheet, the very last section is what's called Dalton's law. It's the first law of gases that I'll introduce to you, but it's by far the easiest, most logical one. So it fits well into our day of multiple skills. Dalton's law states something simple. It says that if you have a system that's broken up into different partial areas, it's been compartmentalized, or you have a mixture of different gases, that the pressure of each gas added together will give you the total pressure of the entire system. You're writing, right? I'll say that again. If I had a system that was compartmentalized, or it was a mixture of different gases, all I would have to do is add up all of those individual pressures together to get the total pressure. Now, if you look at this equation on your cheat sheet, there's a dot, dot, dot. What's that called? An ellipsis. It means that the list could go on. The reason the equation uses an ellipsis is that there could be a mixture of any number of types of pressures in this system. In this case, I gave you 6. So we're going to have to add up pressure 1 plus pressure 2 all the way up to plus pressure 6. But there could only be 2. So it all depends on how many partial pressures there are. But the point is to find the total pressure of the entire system. It would be 1 plus 1 plus 2 plus 3 plus 1 plus 4. What do you get? Oh, look, different answers on my addition problem. 1 plus 1 is 2, plus 2 is 4, plus 3 is 7, plus 1 is 8, plus 4 is... which is the total pressure of the system. Dalton's law states to find the total pressure, you have to add up all the partial ones. So it's pretty simple and straightforward as long as you're able to do some 7th grade math. Because I can make it a little funkier. All right, we had a weird container that was broken up into partial pressures of 100 mmHg, 200 mmHg, and we don't know that partial pressure. But I know that it's got a total of 600 mmHg. Don't shout out an answer. You've got to be able to also solve for the missing partial pressure. So we know that these guys added together equal that total. So if you want to use x and be cool, x plus 100 plus 200 equals 600. All right, we know that that plus that should equal the total. And then you could use algebra to solve, though a lot of you don't have to. All right, but to simplify, 100 plus 200 is 300. To get the x by itself, you would subtract 300 from both sides. 600 minus 300 is And now it's true. All right. If you add up all the partial pressures, it equals the total pressure. You try a couple. These are two separate problems. Solve both of those. Let me know if I can help. To find my total pressure of the first system, I know I need to add up the partial ones. So 50 plus 55 plus 60 plus 45 gives me a total of, what did you get? What? 210. What are my units? kPa. All right. Remember, no naked numbers. To find my missing partial pressure, I know that all four of those added together must equal 19.4. So 3.5 plus 2.7 plus 4.6, those three together are 10.8. So I need the difference of 10.8 to get to 19.4. And I get 8.6. Any questions on temperature conversions, pressure conversions, or Dalton's law? You do have a new online assignment, and your unit partners are posted. Have a good day.